this paper number 63 for our binders, so that way you can go through the properties. So for first off, the isosceles trapezoid, we need to select all of the statements that are true. So an isosceles trapezoid on your picture is not only just what's in this box, it's also what a trapezoid is. So whenever you're looking at this, you need to realize it's a family of shapes. So an isosceles trapezoid is not just what's in this box, it's also what's above it. So if I look at the first thing, it says an isosceles trapezoid, we need to determine, are the diagonals congruent? So it says right here, diagonals are congruent. And if you look at your picture, these match. If you need to, you could always draw the little shape off to the side and kind of visualize it. So if you drew in diagonals, those would be the same distance because it's isosceles. So that is true. The next one says consecutive angles are supplementary. So it does not say consecutive angles are supplementary here, but if I look at a trapezoid, because they're connected, they're family members, consecutive angles are supplementary. So for every shape, consecutive angles are technically supplementary for our quadrilaterals. We need to know if isosceles trapezoid have diagonals that bisect. So if I look at isosceles, it says the diagonals are congruent. Over here, does not say diagonals bisect. That's because if I draw in my diagonals, they do not bisect. The bottom piece is longer than the top piece. So next shape is a parallelogram. Parallelogram is at the top of your diagram, which is right here. There is nothing before a parallelogram. So for the parallelogram, you're just looking at this box only. So it says diagonals are congruent. It does not say diagonals are congruent. If you think about it, this piece is longer from corner to corner than this piece. Consecutive angles are supplementary. Consecutive angles are supplementary. That is true. Every shape we've talked about, same side angles add to make 180. And then the diagonals, they crisscross and they cut themselves in half. So the diagonals bisect. That is true. For a rhombus is down here. A rhombus is everything in this box, but it's also in this box because a rhombus is a parallelogram. So when you're looking not only here, but you're looking here because they're connected. It's a family member. So the diagonals are perpendicular, diagonals bisect, diagonals bisect. Diagonals are not congruent. This piece is going to be longer than this piece. Consecutive angles are supplementary. It's not in here, but it is in here because same side angles are going to add to make 180. And then I want to know if the diagonals bisect. The diagonals do bisect. So the next one is find the area of the parallelogram. So that is on your formula sheet. Formula sheet for a parallelogram is area equals base times height. So we're going to write the formula down. The base is not just 7, it's the whole length. So it matches the top. So the whole base is 30. The height we need to find. The height is the straight up height, like when you go to the doctor. You need to know the vertical height, not the slant height. But we have a right triangle, so we're going to do the Pythagorean theorem. So I have a little baby right triangle. The base of it is 7. The hypotenuse is 25. We're going to find A, and that'll be our height. So we're going to do a squared plus 7 squared equals the hypotenuse, which is 25 squared. So 7 squared is 49. I don't know what 25 squared is in the top of my head. So let's do that. 625. I'm going to minus 49 to both sides. So a squared is 576. And then don't forget to square root it. So shift square root. So we get exactly 24, which is nice. So the height is 24. So I'm going to put that in my formula. So I'm doing 24 multiplied by 30, which is 720. The next one is a parallelogram. It says we have to find the measure of H. H is here. Notice there's nothing at H. Opposite angles of a parallelogram are congruent, so that will match with F. But if we're looking at the angles that we're given not opposite angles, we're given same side angles. So this is an acute angle, this is an obtuse angle. They are not the same. They open to different amounts. So if they're on the same side, we're going to add them to make 180. So we're going to do 3x minus 15 plus 7x minus 5, and it's equaled to 180. We are on the same side. So we're going to combine like terms. 3x and 7x is 10x. 15, negative 15 and negative 5 make negative 20. I'm going to add 20 to both sides. So I get 10x equals 200. Divide by 10, x is 20. But that's not the answer. We have to find h. So h is this corner. H is congruent to f. So I'm going to plug it in here. So we're doing 3 times 20, because x is 20, minus 15. $45 degrees. So in this corner would be 45 degrees. For number 4, it says we have another parallelogram. We need to find H to G. So this one, they gave us extra pieces of information. We do not need to use one of the sides. We're only using the sides that are actually congruent to each other. So the sides match each other. This one matches this one, but there's not enough information to solve for Y. This side matches this side. Those are congruent, the top and the bottom. So this is extra information we don't actually need. So I'm going to set these equal. They're congruent. Y plus 18. They are congruent. Opposite sides are congruent. And we're going to subtract 2. So 3y equals y plus 16. And then I'm going to minus 1y to both sides, because this is like a 1 if you want to put a 1 there. Minus 1y. People get confused when there's just a y. 3y minus 1y is 2y equals 16. So y equals 8. That's not the answer, because I need hg. So I'm going to plug it back in to hg. hg is this piece. So y is 8. So we're doing 8 plus 18. So 26. And it's a length, so it doesn't even need a little bubble, because it's not a degree, it's not an angle. The next one is a formula not on your reference sheet. You do need to know this for your EOC. You do need to know it for the test. It says in the figure, XV is the midsegment of our SUT. If RS is 30 and XV is 44, we need to find TU. Because there's a missing piece, we're going to call it X. So the formula is, I'll put it off to the side, base 1 plus base 2 divided by 2. So we're taking the top, we're adding the bottom, and we're dividing by 2. So 30 plus X divided by 2 equals the midsegment, which we know needs to be 44. I'm going to get rid of the 2 using opposite operations, just like I would do addition and subtraction. I'm going to get rid of division by multiplying by 2. So it gets rid of it, gets it out. So I'm left with 30 plus X equals 44 times 2 is 88. I got to get X by itself, so I'm minus 30 to both sides. So X equals 58. So B. 6 says select all the conditions that prove a quadrilateral is a rectangle. So whenever you're looking at this, whenever you're doing this one, I would use that sheet of paper look at here. We have to prove that a rectangle is a quadrilateral or a parallelogram. What's it say? Quadrilateral is a rectangle. So a rectangle is not just these properties. It's a family tree. So a rectangle is also a parallelogram. So anything in these two boxes makes a rectangle. So if it says both pairs of opposite sides are congruent, opposite sides are congruent. So that's true. One pair of opposite sides is longer than another pair of sides. That is technically true, but we do not circle it because it's not one of our properties, because technically a square is also a rectangle and a parallelogram. And so that does not count. It's not one of our things in our two boxes. The diagonals bisect each other. That is not one of our, or that is one of our things. I'm sorry. So diagonals bisect each other. I was thinking angles, not diagonals. The diagonals are congruent. The diagonals are congruent for a rectangle, not a parallelogram. So because we're talking about rectangles, diagonals are congruent. And then the last thing is diagonals are perpendicular. So these do not make right angles in the center. The only ones that do are rhombus and squares. So you have three answers, A, C, and D. For the proof, this one says ABCD is a parallelogram, which is true. AB is parallel to CD, which is true, but we don't mark it because it's not a congruency statement. Opposite sides of parallelogram are parallel. They're parallel. That makes sense. AC is a transversal. That's true because definition of a transversal. The next part is a congruency statement. So I mark it in my picture. It says CBE, so this angle, is congruent to ADE, which is this angle. Those are true. That is because alternate interior angles theorem from chapter 3. They jump across the transversal. They're inside the parallel lines. The next one, you have to choose the correct thing. You're looking for a pair of vertical angles. This one's actually a little tricky. It says AED. I'm going to use a pencil. It says AED, AED, which is here, is the same as BEC, which is here. Those are vertical angles. That is true. The next one says AEB, which is here, and CED, which is here. Those are vertical angles. That is true. The next one says ABE, which is here, and CDE, which is here. Those are alternate interior angles. That is automatically out. Now, the problem is you have two possible answers. When you look at what you're trying to get to, you're trying to prove that CBE is congruent to ADE. You want to know that these triangles are congruent. So if I like lightly highlight this, CBE, the top triangle is congruent to the bottom triangle. You need the information that's actually in those triangles. So we need to know that these ones are the same. We don't care about the stuff on the outside of the triangle. So technically the correct answer is the top one, which is A. And I mark it in my picture because it's a congruency statement. So I marked it and I marked it. I also have these angles and now I have like a pink smear in the other triangle, but it's great. The next one says BE, so I'm going to mark it, is congruent to DE. I mark it. So the sides are congruent. That's because opposite sides of a parallelogram are supposed to be parallel. Opposite sides of a parallelogram are congruent, or diagonals of a parallelogram bisect. It's because you're inside the shape, the diagonal is being split in half because the diagonal is being cut in half. It's a congruency statement. You mark it. The next thing, based on the markings you have, you pick your theorem. So to know that CBE and triangle ADE are congruent, you have an angle, you have a side, and you have an angle. You cannot use AAS for this because the side is between the A's. It's in the middle. So this is ASA. The last one, once you have this statement proved, the next step will always be corresponding parts of congruent triangles are congruent because it's saying that the other piece of the triangle is also congruent. AE does match CE. That's because once you know they're congruent, everything else in those triangles actually match each other. Okay, number 8 is a rectangle. 50 degrees can move, vertical angles are congruent, so 50 can go here. And then you have a triangle. A triangle adds to make 180. So if I take 180 and I'm minus 50, I get 130, but 130 has to be split between the two angles I have in that triangle. So I divide by 2, I get 65. It is symmetric, so 65 can also go here, and 65 can also go here. Each corner in total of a rectangle makes 90. So if I take 90 and I minus 65, I get 25. 25 can go here. 25 can go here. 25 can go here. 25 can go here. And then the last thing you got to do is make a triangle again. Another triangle is going to add to make 180. So I have this bottom triangle. I have two 25s. I need this big angle at the top. So I take 180. I minus both 25s. So I get 130 for this angle, and then vertical angles are congruent. So now we just got to fill in our answers. So it says M, N, J. So that's 50, which is B. The next one says M, J, N, which is 65, which is C. The last one says M, L, N, which is 25, which is A. The next one has a number that's crossed out because the hole punch. So this is 30 or 300 yards. It's just hole punched out. That's supposed to be there. A field is shaped like a trapezoid shown. From your formula sheet, we're going to use the formula for a trapezoid. So it's the top formulas. So this formula, area equals 1/2 height times base 1 plus base 2. So this is your height. That's my H. This is base 1. This is base 2. Turn on lights. So 1/2. My height is 150. Base 1 is 150. Base 2 is 300. Once again, it's just hole punched out, so you should have that number. 150 plus 300 is 450. And then I multiply straight across. So 450 times 150 times 1/2 is 33,750 yards. On the back, it says you have a trapezoid. A lot of people are plotting your points wrong, so that's where you're going a little wrong here. 0, 0 is here. 0, 6 is here over 0 up 6. So that's Q. R is 8, 6. And then S is 14, 0. So if I connect them, it makes a trapezoid. You want to know the mid-segment. The mid-segment formula is where you take the bases and you divide by 2. So if I count the top has a length of 8 because I'm just counting across. So the top is 8. The bottom is 14. So we're doing 8 plus 14 divided by 2. So 8 plus 14 is 22. Divided by 2 is 11. 10 is another trapezoid problem. So this is just like a repeat problem for you to practice. So we're using the same formula for the area. 1/2 height times base 1 plus base 2. So my height in this case is 4. Base 1 is 5. Base 2 is 12. 5 plus 12 is 17. So we're going to multiply them together. So 1/2 times 4 times 17 is 34. 11 says one pair of base angles of an isosceles trapezoid has the measure of 3 times x minus 8. The other pair has 2x plus 4. So what this means is each pair technically, so 2x plus 4 can go here. Each pair has the same amount because it's isosceles, so they match. So you actually have doubles of everything. You can either add them all up to make a quadrilateral, which is 360, or you can do half of it, which is what most people are doing. Half, these do not equal each other. They are not congruent. Same side angles, consecutive angles add to make 180. So we're going to add them to make 180 to find the value of x. So I'm going to do 2x plus 4, and I'm adding 3x minus 8 equals 180. So I do have to get rid of my parentheses, so I'm going to distribute. So 2x plus 4 stays the same. 3 times x is 3x. 3 times negative 8 is negative 24. And now I can combine my terms. 2x and 3x make 5x. 4 and negative 24 make negative 20. I'm going to add 20 to both sides. So 5x equals 200. So x is 40. The next one is a repeat problem. So this is where I'm just making extra problems for you to practice with. We're going to go back to our thing. We're talking about isosceles trapezoids. So here's our two trapezoids. It says opposite angles bisect. That is not true. Opposite angles do not bisect. Opposite angles are congruent. For isosceles, that is not true. For a trapezoid, that is not true. Diagonals are congruent. That's the only one that's true. Your diagonals are the same length. They don't bisect, but they are the same length. The next one is a parallelogram. Parallelogram is only the top shape. That's only this top one right here. Parallelogram has nothing before it. Opposite angles bisect. That's not true. Opposite angles are congruent. That is true because A and C are congruent, B and D are congruent. Diagonals are congruent. That's not true. A rhombus is right here, which is everything in the rhombus box, but it's also a parallelogram because it's a little family tree. So it's everything in these two boxes. So a rhombus, opposite angles, they do bisect. Diagonals bisect opposite angles. So the angles bisect. Opposite angles are congruent. That is true. Diagonals are congruent. That is not true. Okay. Next one is another problem from one on the front. We're going to find x, y, and the angles and the sides. So let's start with x. X is looking at the inside. We have this angle and this angle. They are on the same side. They do not equal each other. That's acute and obtuse. So we're going to add to make 180. So 3x plus 15 plus 7x plus 5 equals 180. So 3x and 7x make 10x. 15 and 5 make 20. I'm going to minus 20 to both sides. 10x equals 160. When I divide by 10, x is 16. So x is 16. Let's find the angle. Let's jump down to the angle. So I need H, E, F. Remember, it's just the middle letter. So I'm just looking for E. E is not the same as F. It's the same as G. So I'm going to plug it into G because opposite angles are congruent. So if I do 7 times 16 and I add 5 because that's the equation that I have to use for this corner. So 7 times 16 plus 5 is 117 degrees. Now let's do the y. Let me use a different color. So your y's are your sides. Once again, you have a top and you have a bottom. You also have a spare side. The rule is that the top is going to match the bottom because they're side lengths. So we're going to equal them to each other. So we have 3y equals y plus 8. We don't have any numbers, so I'm not going to minus numbers. I'm going to move the y's first. So I'm going to move this 1y. So I'm going to subtract 1y. So I have 2y equals 8, y equals 4. And then I have to plug it into GF. GF is this side. So I'm not going to plug it into the top or the bottom. I'm actually going to plug it into this side. So we're going to plug it in here. So we have 2, but I have 4 for y. So 4 plus 1. So 4 plus 1 is 5. 2 times 5 is 10. (14) is another problem of mid-segment, so extra practice. It says TU is 45. XV is 36. We need to find RS, so I'm going to put a little X at the top. So I'm doing top plus bottom. Divide by 2 equals the middle, which is 36. So I got to get rid of the 2 using multiplication. So multiply by 2, multiply by 2, cross it out. X plus 45 equals 72. Now I'm going to minus 45 to both sides. X equals 27. 16 is just like number 11. It says one pair of base angles is 2 times 5x plus 1. One pair is 3 times 2x plus or minus 2. We're going to add them and equal it to 180. So 2 times 5x plus 1 plus 3 times 2x minus 1, and it's equal to 180. So we have a double distributive property. 2 times 5 is 10x. 2 times 1 is 2. 3 times 2 is 6. 3 times negative 1 is negative 3. We're going to combine like terms. So I'm going to combine 10x and 6x. That makes 16x. And then I'm combining 2 and negative 3. That makes negative 1. I'm going to add 1 and divide by 16. This one you do get a decimal for, so hopefully you're not scared of that. So 181. What the heck? I messed up somewhere. 10, 2, 6, negative 3. Oh, I wrote the problem wrong. 2x minus 2. This is a 2. Oops. So this is a 6. Hold on, wind up. So 3 times negative 2 is negative 6. When you combine 2 and negative 6, you get negative 4. So I add 4. So you get a decimal, but it's not like super ugly. Divided by 16. There we go. X is 11.5. Not bad. Okay, the last one is a practice problem of the proof. So let's go through this one. So for the proof, the first thing is given. That's because it's given. MJ is parallel to LK. You don't need to write anything because they're telling you that they're parallel, so opposite sides are parallel. JL is a transversal. That's because you're talking about a transversal, so it's definition of transversal. The next one says that JMN adds with NML to make 90 because they're both in this corner. So they do add to make 90. The only reason down below that would make sense for that is definition of a right angle. The next one actually wants to know alternate angles that are congruent. So you're looking for angles that are congruent. So down in your word bank, if I cross off the ones I already used, there are only two angles down here that are your possibilities. This one and this one. The only one that actually makes vertical or alternate interior angles is JMN and LKN. If you mark those, JMN is here and LKN is here. If you compare that to the other set of angles that are given, they are vertical angles, and that would be here and here. So alternate interior angles have to jump across the transversal. So for alternate interior, it should be JMN is congruent to LKN. The other angles, the only other option is a set of vertical angles, which you cannot use because these are vertical, so it doesn't work. The next one says, so we marked it on our picture because it's a congruency statement. The next one is a congruency statement. We have to mark it on our picture. It says MJ matches LK. That's because opposite sides are congruent. The next one is a congruency statement. We mark it in our picture. It says MN matches with KN. So those are congruent. The reason why you're talking about the inside, the only one that would make sense is that your diagonals bisect, meaning they split. And then if you actually look at one of the triangles that you just filled in, so if I just focus on this one, you have an angle in the middle and you have two sides around it. So this is SAS because you cannot say ASS, can't cuss. So if you have two sides and an angle, it has to be side, angle, side. After that, it's saying that JN is congruent to NL, which is true. You could add that to your picture. But once you know that the triangles are congruent, corresponding parts of congruent triangles are congruent, tells you everything else in that triangle is also going to be congruent. So CPCTC will always be the last step for these because it's proving everything else is the same or equal.